Welcome back, everybody. This is our second session in NEET previous year questions for chapter Alternating Current of class 12th. Before this video, we have made one video in this series, and that video is available on channel's playlist section. We have also started similar series for JE previous years. So if some of your friends are preparing for JE, or if you want some additional practice, then you can watch those videos also. They are also available in the playlist section of the channel. And if you find these videos useful, then do press the like button, share it, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video. In the previous one, we covered up to, I think, question 10. This is we covered. This is we covered. Okay, so we will start with question number 12. Now, as per statement in the LCR circuit, we have a inductor, capacitor, and resistance. The frequency at which response occur is. So we have to find the response frequency, or in short, we have to find its resonance frequency at which current is maximum, and we can say impedance is minimum. At resonance, you can say at resonance frequency, XL is equal to XC and Z becomes equal to R. So we have to find that frequency, and that frequency is given by 1 by under root 1 by LC. That is the frequency, and that we can find value of L is 10 millihenry and capacitance is 1 microfarad. So this will be 10 raised to power minus 8, 10 raised to power minus 9 into 10, 10 raised to power minus 8. And this will, you can write like this, under root 10 raised to power 8. So that will be 10 raised to power 4 by 2 pi, or 5 into 10 raised to power 3 by pi. Now, so frequency will be in kilohertz, and 5 by pi, we know pi is 3. So if we approximate pi by 5 by 3, that will be approximate 1.33 something, and it should be slightly less. Oh, sorry, it will be 1.67. 5 by 3 is 1.67, and if we divide 5 by 3.14, then it will be slightly less, around 1.5, which we have in option, that 1.59 kilohertz. So it will be 1.59 into 10 raised to power 3 means kilohertz. So option B will be the right answer here. Let's move to the next one. The net impedance of the circuit will be. So we have to find out the net impedance of the circuit. For that, we need to calculate the individual components. So in the impedance term, we have R square plus XC minus XL square. So value of R is 10 ohm, and XL, let's calculate. XL will be omega times L. Omega is 2 pi into frequency, that is 50, into L, that is 50 by pi. So pi get cancelled, and this will be 100 into 50, that will be 5000. That is 5000. Now XC will be 1 by omega C. So again 2 pi into 50, and C is 10 raised to power 3 by pi microfarad, 10 raised to power minus 6. So again pi cancelled, 50 into 100 into 10 raised to power 3, that will be 10 raised to power 5 into 10 raised to power minus 6, so 1 by 10 raised to power minus 1 or 10 ohms. So I think, okay, we missed one thing. This was millihenry. So we have 10 raised to power minus 3 here. So 10 raised to power minus 3 here, and we get 5 ohm. So XL is 5, X is 10. Now Z will be 10 square plus 10 minus 5 square, that is 5 square. 5 square. So it will be 100 plus 25, 125 under root, or we can write it like 5 root 5. That is option A for us. Let's move to the next one. A series LCR circuit with inductance 10 Henry, capacitance 10 microfarad, resistance 50 ohm is connected to a AC circuit of this voltage. If the resonant frequency of the LCR circuit is V0, the frequency of the AC source is V. Okay, so first of all, frequency of the AC source is this. We know that we can write potential like this, that V is equal to V node sine of omega t. So here omega, in case of AC source, comparing this equation with the equation of the AC source, omega is 100, or we can say 2 pi times the frequency is 100, or frequency of the AC source is 50 by pi hertz. This is the frequency of AC source. So it is mentioned as V. So frequency of AC source is this. So in this option it is 50 by pi, so it is wrong. In this option it is 50 by pi, oh sorry, again 50, that is wrong. And in this option it is not mentioned, both V node are mentioned. So suppose if even if this is frequency, then again this is wrong. So option B should be the answer, but let us find out V node. And V node is the resonant frequency. So we know resonant frequency is given by this relation, 1 by 2 pi into under root 1 by LC. So L is 10 Henry and capacitance is 10 microfarad. So 10 into 10 raised to power minus 6. So this will be 10 into 10 raised to power minus 4, or 10 into 2 into 10 raised to power minus 6. So 10 raised to power minus 4. And it can be written as like this, 1 by root 2 pi into 10 raised to power 4. It will be 100 by 2 pi, and that will be 50 by pi hertz. So both frequencies are equal. Option B will be the right answer here. Let's move to the next one. An inductor of inductance L, a capacitor of capacitance C, and resistance R collected in series in a AC source, potential difference V volt as shown. So across the inductor we have 40 volt, across the capacitor we have 10 volt, and across the resistance we have 40 volts again. Potential difference across is mentioned, the amplitude of the current flowing in the LCR circuit. So current is given, impedance we have to find out. Now impedance we can calculate only if we know the value of both voltage and current, because we know that I RMS, or value of the current, that will be Vrms by Z. So from this we can write that Z is equal to Vrms by Irms. Now value of Irms we have, that is 10 root 2. We have to find value of Vrms, and that we can do as we have formula for impedance, that is r square plus xc minus xl square. Similarly, if we multiply this with current, then we can form equation that potential is given by VR square plus VC minus VL square. So this is the net potential of the circuit. So net potential will be resistance, potential across resistance, that is 40 volts. So square, that will be 600. Now VC minus VL, 10 minus 40, that will be minus 30, square of that will be 300, 900, and under root will be give us 50 volts. So value of the EMF, that will be 50 volts. And here we need to clearly read this statement here, that amplitude of the current is given. So amplitude means the peak value of the current is given. It's not the RMS value of the current. RMS value will be root divided by root 2. This will be the RMS value. This is the amplitude or the peak value. So VRMS, that we have 50, and RMS value of the current will be 10 root 2 divided by root 2, that will be 10. So our impedance will be 5 ohm. That is option D. Let's move to the next one. When circuit is connected to an AC source of 12 volt gives current 0.2 ampere. Same circuit when connected to DC source 12 volt gives current of 0.4 ampere. The circuit is. So here, in case of AC, current is less, or we can say total impedance of the circuit is greater. But in case of DC, total impedance, the current becomes higher, and so total impedance of the circuit is reduced. Now, to solve this type of question, let's examine all the possible scenarios. As we don't know that the circuit is either LR or, so what we do, we examine all the circuits. So let's start with the option A, that we have a series LR circuit. So in series LR circuit, what we will have, we have an inductor and we have a resistance. Now in case of AC, what we will have, there will be some resistance or thus some impedance due to this inductor, that will be XL, and that there will be some value of the resistance. So current in case of AC in this circuit, IAC, will be given by value of the potential divided by R square plus XL square. This is for AC. Now in case of DC, as frequency of DC is 0, so current resistance offered by the inductor will be 0. So I DC will be V by just R. So we can say in case of DC, resistance is decrease. Resistance is decrease means current can increase, which is as par with the given statement that in case of AC, current is less, and in case of DC, current is higher. So option A can be a answer. Now coming to RC circuit. So if we have a RC circuit, then our circuit will look like this. And we know capacitor does not conduct DC. So in case of DC, we will not get any current. So if we can say, if a circuit has capacitor, then that will be straightforwardly neglected in case of DC. And as we have DC current, so this circuit will be neglected. Again, this circuit will be neglected. And the only left, we have option of LCR. We cannot neglect LCR circuit if they are in parallel. Means our circuit can be something like this, that we have a resistance, we have an inductor, and capacitor in parallel. If they are in series, then again capacitor will not conduct, and that will not be the possible answer. But if they are in parallel, there are chances. But we have it is specifically mentioned that they are in series. So again, in series capacitor will not conduct, so this is again not a possible answer. So option A is the only possible answer here. Let us move to the next one. Figure shows a circuit contains three identical resistors R, each of 9 ohm, two identical inductors, each of L 2 millihenry, and an ideal battery of 18 volts. The current I through the battery just after switch S is closed. So when just this switch is closed, so we have two type of behavior for inductor and capacitor. So initially, when current starts flowing, when current starts building in the circuit, inductor does not allow any we can say any current through it, because it opposes any change of the current, and initially in circuit there was no current, so inductor opposes the current. Or we can say, in case of initial at t is equal to 0, inductor act as open circuit. And for capacitor it is reverse. Capacitor after charging does not allow any type of current, and initially it allows current. So at t is equal to 0, capacitor work as short circuit. So as we have been asked to solve this we can say circuit when switch is just closed, means after closing the switch we need to find the value. So here this capacitor will act as open, this inductor will act as open circuit, this inductor will act as open circuit, and this capacitor will act as a short circuit. So our circuit will look like something like this. We have a battery here, this path is broken, we have a resistance here, here inductor will act as an open circuit, so this path is broken. Again we have a resistance here, and this path is again broken because the inductor, but this path is connected due to the capacitor. So as a whole our circuit can be reduced to this form, that we have a battery here, this R is not in the circuit, and we have R and R in parallel, and their combined resistance will be R by 2 in parallel. Now value of battery is 18 volt, so current in the circuit, initial current in the circuit will be 18 by value of R is 9 by 2, so this will be 4 ampere. Option C will be the right answer. Let's move to the next one. A series RC circuit is connected to an alternating voltage source. Consider two situations. When capacitor is air filled, when capacitor is mica filled, current through resistance is I and voltage across capacitor is V. So we have to find that which of the situation will be true. So let us discuss the possible scenarios. So let's first analyze the capacitance. We have a air filled and we have mica filled. Suppose all other means area, the width between the plates is equal, then we can say capacitance of the mica filled capacitor will be we can say epsilon times or dielectric times the capacitance of the air filled capacitor. So capacitance of the mica field will be higher. Now as mentioned that the source is AC source, so we know for in case of AC source, impedance of a capacitor is given by 1 by omega c, or impedance is inversely proportional to the value of the capacitance. So from this we can say impedance of air capacitor will be greater as compared to impedance of the mica capacitor. And as we have to find out current through resistor and voltage across capacitor, so total impedance that is given by Z, and that is square root and sum of R square plus XC square. As in case of air, impedance X air is higher, so we can say Z air will be higher as compared to Z mica, and current will follow the inverse relation as current is potential by the impedance. So we can say current of air will be smaller as compared to current of mica or mica. Now value of resistance is fixed, and value of resistance or potential value of potential drop across the resistance is given by V is equal to IR. Now in case of air, air filled capacitor, this value, let me write it clearly. In case of air filled capacitor, value potential drop across resistance R, VR, will be I air into its resistance. Now same for mica filled capacitor, suppose that is V dash R will be I mica multiply by R. And as if we can if we divide both of these, VR by VR dash will be I air by I mica, and as I air by I mica will be less than 1 because I mica is greater than I air, so it will be less than 1, or we can say VR is less than VR dash, means potential or voltage across the resistance in case of mica capacitor will be higher, and that is denoted by V2 here, and in case of air it is denoted by V1. So we can say V1 is lesser than V2. That is option A for us. And for current, this will be I1 lesser than I2, and we don't have this relation. We have been given inverse relation. I1 is greater than I2 is given, so that is wrong. So option A will be the right answer here. Let's move to the next one. A coil has a resistance of 30 ohm, inductive reactance of 20 ohm, and frequency 50 hertz. If AC source of 200 volt 100 hertz is connected across the coil, the current in the coil. So we have to find out current in the coil. For that, we need to calculate the total impedance of the circuit. And after calculating total impedance, we can calculate the current in the circuit. So for that, we have total impedance is combination of resistance, inductor, and capacitor. We only have inductor here, and its inductive reactance is given 20 and resistance is 30 ohm. So it will be XL square plus R square plus XL square. That will be 30 square is 900, 20 square is 400. So it will be root 30, 1300, or 10 root 13. This will be the value of impedance at 50 hertz. But we have been asked to find the current at 100 hertz. So we have to find this value at the 100 hertz. Now we know that XL is equal to omega L. So right now what we have been given? We have been given 2 pi into frequency, that is 50 into L. We have been given this value, and this value is equal to 20 pi inductive reactance of the inductor, and we have to calculate it at 100 hertz. So how we can calculate it at 100 hertz? We can simply multiply it by 2. Twice of 2 pi into 50 into L will be twice of 20, and this will be 2 pi into 100 into L is equal to 40. So that is omega into L at 100 hertz. So at 100 hertz, inductive reactance will be 40 ohm, and from that total impedance will be R square, that is 900, and XL square, that will be 1600, that will be equal to 50 ohm. So Z value of Z is 50 ohm. Now we can calculate the current. So current will be potential, that is 200, divided by the impedance total, that is 50. So 4 ampere will be the value of current. So option A will be the right answer here. Let's move to the next one. An AC voltage is applied to a resistance R and inductor L in series. So R and L both are in series. If R and the inductive reactance are both equal to 3 ohm, phase difference between the applied voltage and the current is. So now phase difference is given by tangent phi. Tangent phi is XC minus XL divided by R. Here we don't have a capacitor, so it will be equal to XL by R. So XL or inductive reactance, that is 3, and the resistance is also 3. So 3 by 3 is 1. So tangent phi is 1, or we can say phi will be 45 or pi by 4 radian. That is option A for us. So with this, I end this video here. Hopefully whatever I have covered till now is helpful to you and understandable also. Again, if you have any doubts or suggestion, you can put them in comment section. I will try to resolve them. And if you find this video helpful, then do press the like button, share it, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.